Hi, here I'm to talk about the annual allowable cut, the AAC, in regards to volume-based approach. The first video was all about looking at it from area-based, and now I want to look at it from a volume-based approach. So first of all, what we want to look at here is just a recap here. Why we look at these things is why do we look at timber supply? What's so important about that? Well, a couple of reasons that make it very important. And the first one is the economic environment. So the timber supply is influenced by the economic environment. What that means is, for example, right now, a bit of the downturn still we're feeling from the States. We're finding it a slower time, especially in Ontario, in regards to the economy. This has resulted in our timber supply being we have lots of timber currently available, and so we're very much in Canada governed by what happens around the world, because we export the majority of our wood. The other thing that influences timber supply is policy, and policy means the Ontario Ministry of Natural Resources. What are the policies? And this could tie into species at risk, could tie into old growth forest, it could tie into policies around multiple use, like remote lodges, mining, fishing, hunting, angling. It can be many things like that can influence the timber supply that is made available. The next one is the biology. Some trees just grow plain slower than others, and based on their location, their productivity of how fast they can reach maturity is definitely governed by the biology and, of course, the location in the province. And a very typical one is the topography of the forest. If you grow, for example, hard maple around Rice Lake south of here, about an hour, the hard maples are fantastic. They grow unbelievable. They have very small hearts in the middle, as they're called, or brown area. While if you come up to Bob Cage in the north, the topography is far more rugged, very shallow soils, and the quality of the wood is dramatically lower. So all these things have to be considered if you're going to plan out your timber supply. So in Canada, who does all that figuring out? Well, in Canada, the provinces are responsible for the natural resources, and that's the only ones that are. Natural resources are governed by the province. So just as a recap here on, we're going to be talking, when we talk about volume, we're going to be talking about cubic meters. And a lot of people can't relate to what the heck is a cubic meter. Everyone can tell you, yes, a cubic meter is 1 meter high, it is 1 meter wide, and it's really crooked lines, and 1 meter deep. And if you add that box up, you'd have 1 meter cube. But we talk about that in forestry all the time, so let's just kind of think about it this way. 1 meter cubed is roughly the amount of wood you would find in one telephone pole. Okay? And that's generally, and so when we talk about volume of wood, okay, it's always important to remember when we talk meters cubed, we're talking about solid wood, excluding bark, excluding defect. So in just how much wood do we harvest like that in Ontario? In a good year, it's about 24 million meters cubed harvested annually. And that's only like 1% of the total cut per year, very low. Sounds like a lot, but it's not that high. So if you look here, I have some more, these stats are a little bit dated, but that's okay. I'm not too worried about that. It's just so you understand the magnitude of the numbers, and you can see that the provincial total is there, and this is for the year around the year 2000, 12 years ago, but really it's anything, it hasn't much changed. The key thing I wanted you to note, like the last time, what are the major species? Here it is: poplar for the hardwoods, and spruce follow right away after jack pine are our major species that we harvest in this province. Okay, so I want you to note that. So and the tree of Ontario, again, which is white pine, represents a very small amount of the actual harvest. Okay, so let's dive into, we got one more graph. This graph again illustrates how much wood, this graph here, each different color represents a different year, and you can see the amount of harvest. This is the amount of wood that's harvested. This is the amount that has been eaten by insects over the same number of years, disease, weather, and wildfire. So this can wildly fluctuate over the years, the actual wildfires. Okay, so we generally say kind of a rule is that 1/3 is harvested, 1/3 is lost to insects and disease, and 1/3 is lost to fire, and that seems to be what it is across the country. Okay, so what I want to look at now is volume calculations for even age stand management. So how do we figure out how much wood is removed? The volume, because volume is what's important in calculating how much wood is going to the mill. So let's look at that process now, and there's a bit of math, not too much, so don't. First, the forest is divided into age classes. Now let's assume the forest is all one species, okay, in this imaginary forest. Then you determine the available volume to harvest over the area by finding the growth of the forest. By finding the growth of the forest. And what we want, when we determine that, we hope the forest is quite normalized. That's a fancy way of saying that it has a sustainable growth, like here, like we talked about in the last video, an equal amount of area in each age class until the point it reaches harvest, right here. Okay? So, we assume, okay, that the forest is growing, and this is a nice forest, it is growing 1.6 meters cubed per hectare per year. So over the whole forest, that's the assumption we make. Okay, for this particular forest. If you look at this little chart here, you can see, depends where you are, and if the more north you are, the slower is the growth rate. And if you're more south, let's say the coastal forest of BC, the growth rates can be dramatically better. Okay, so this gives you just the idea how much volume are we putting on per hectare per year. So if you know that, and here the assumption is 1.6 meters cubed per hectare per year, and let's say we have 1,000 hectares of forest. Therefore, 1.6 times 1,000 means we are having added to the forest this amount of volume per year. Well, what does that mean as far as what can you take from the forest? Because you cannot obviously harvest stands that are 30 years old, so you cannot take it all from there. Any of it, I mean, excuse me. So you calculate the volume for each forest stand of, here's the key word, harvestable age. So, harvestable age, we're going to say any forest that's 80 years of age. So you go 1.63 meters cubed per hectare per year, right? So that's how much was harvested, I mean, the forest grows per year, times 80 years. So that means theoretically that stand that stand has 128 meters cubed of volume at harvest per year. per hectare, excuse me. So it's 128 meters cubed of wood per hectare. Then you would multiply by the number of hectares to find the total area, and that's what we do here. Okay, so here we calculate the number of hectares. So let's pretend, so how many hectares do we have? Let me just hit the escape button here. So here, how many hectares can we harvest to be on a sustainable basis? We know we have 1,600 meters cubed of growth per year over the whole forest. We know that 1 hectare of forest produces 128 meters cubed at 80 years. So therefore, if we divide that number, the amount of volume in an 80-year-old forest into 1,600, that tells us we can harvest per year 12.5 hectares. And this is the basic approach, and how do they use volume to calculate how many hectares they can harvest on a sustainable basis based on a specific growth rate. Okay? So, a couple of things based on that information I just spoke to you about. One thing is they have to make some assumptions about how fast is the forest growing. Last week you had to do permanent growth plots. And why do they do them? So we can calculate a few things along the way. And one of them is, what is the site class? Okay, so for example, here we have site class 1, and the way site class is calculated is we track a forest over time, okay, and we measure the height of the trees. Usually we say 50 years at the 50-year mark, or it could be 60. We measure that species at that particular point, and we determine its height. Okay. And if you measure it at 3 different sites, you'll note that the height is different for the very same aged trees. The reason being that the actual site has poor growing conditions the lower the graph. So a site class 3 jack pine stand would be a slower growing, poorer growing area compared to a site class 1. So that's called a site class index. So site class 1, 2, 3. Okay? So that's based on height. So you can see that in an FRI map, this is jack pine 100% is on site class 1, and this is the volume that there is currently there. So we use site class as a way of illustrating what is the growth potential for that area. Here, the other thing we look at in a forest is how much volume is produced over time. So here I just have 100 meters cubed per hectare. It's just this line just to give you a sense of value. And we track the forest, this stand of trees over time. And as the forest grows older, okay, so we could say let's say that's the 50-year mark, we can determine based on doing many studies like permanent growth plots, what is the volume we would expect for different stands based on what they're tracking. So for example, if I measure at a certain age, okay, whoops, let me try that. If you have let's try that again. If I have a stand which is this age right here, and if we track that straight up, here we go with my crooked line, whoa, that looks, whoa, here we go, to there, and then and then we come across to here, we can then say we know the volume for that particular forest. So we use these graphs to help indicate, once we know what kind of forest it is, like class 1, and we know how old it is, we can predict how much volume is currently there just by using this graph. And this is called a yield curve. In other words, how much volume is yielded out of the forest. So many yield curves, which are volume per hectare over time, can be constructed to best represent the forest. Okay, and here we have yield curves. Okay, so the assumptions made about these yield curves can greatly influence the annual allowable cut. I know where I worked, we discussed for a long time, what are we going to assume, how do we assume the forest is going to grow over time, and we had to make assumptions. And so it's very important, the data that's collected by forest techs, to make accurate assumptions. And these curves can be influenced by different things. For example, if you do intensive management like Sweden, or even fertilization, which is very excessive, or more basic things like thinning and cleaning, you can influence the volume that's put on in a stand of trees over time. So that was for even age management. In uneven age management, it's a little different. What we do, first of all, where would we use uneven age management? We use it, and a key thing is we use it in tolerant or semi-tolerant to shade trees. Hard maple, beech, red oak, white ash, and so on. So what do we do here? How do we manage a forest that has all these different age classes, and we're trying to figure out when do we cut? Well, what they do is in Ontario is that they do something where we take the forest. Let me see if I can grab a different color. Nope. Let me try that again. Yellow. There we go. So if you can see here, and this is called a sawtooth graph, and you can see how it goes up, and then what it means is over the span of, then we let the forest grow for 20 years, then we cut it down, and what are we cutting it down to? We're cutting down the basal area. So we let the basal area grow up to about 30 meters squared per hectare. Then we cut 1/3 of it out. So it's like weeding the carrot patch, and the remaining trees. So this comes straight down the basal area because there's less trees there. So the basal area drops. But then what happens over the next 20 years? That the remaining trees and the trees that are coming in, like as understory and advanced regeneration, they grow, and the forest comes back up to there, and then we cut it again, straight down. So this is called a sawtooth approach, okay? Because it looks like a sawtooth, of course, okay? And you can see basically we have a 20-year cutting cycle, and we're removing each time we're removing 10 meters squared per hectare of basal area, which represents volume, which I'll explain in a minute. So how do we calculate from that the actual volume? Because basal area doesn't give us volume, but it is an indirect approach to get us there. Well, first thing is we have to calculate the length of time required to allow the stand to grow back to its maximum basal area. In this example, it takes 20 years, right? It takes 20 years to get there. So from, and if it's up in northern, let's say up in Algonquin Park, that could be 25 years. If that was down in southern Ontario, it could be as short as 15, even 10 years. But generally in Ontario, you could say 10 to 15 years. It just it's such a big province, the range is quite extensive. But it takes a while. So what you do is the following approach to figure this out. First of all, you calculate the total basal area removed per stand for the cutting cycle. So in this case, we're removing 10 meters squared per hectare over 20 years. Because a typical mature stand has about that kind of volume in it. Okay? So you go, well, how does those two numbers relate? Well, 1 meter cubed per hectare roughly is 4 meters cubed per hectare. Therefore, we are harvesting 40 meters cubed per hectare. And how did I get that? 4 meters cubed per hectare, right? 1 meter squared per hectare equals 4 meters cubed per hectare. This is basal area, this is volume. Therefore, 10 times 4 is 40 meters cubed per hectare, which is about one third of this total value, which makes sense, doesn't it? Because we're removing 1/3 of the basal area. So it does come very close together. So you calculate the annual allowable cut for all your forest by adding up the individual harvested volumes from all the stands that have met the requirement that they have reached the optimum basal area for harvest. And that's going this top green line, and you're going to reduce it down to the lower green line. And these areas, selected areas, will be reharvested in 20 years again. And this is cool because for woodlot owners, they always can't imagine how does it work. And then by doing this, you have a constant income over time from a forest without ever losing your forest. This is the wonderful thing about this approach. The last thing I want to talk about, oops, excuse me, I jumped there. Let me just go there. We were there, yeah, sorry. So the last thing is, just as a recap again, and I just like to mention, just a note, in the last 20 years, more area has been affected by fire, insects, disease than has actually been harvested. Natural disturbance affects about 0.6% of the area of Canada, and harvesting affects about 0.4% of all the forest of Canada. So 1% disturbance over the entire country. Which is, and being such a big country, this number always looks scary when you look at it. But I have to appreciate on the country that is as huge as Canada, 880,000 hectares of harvest, which is less right now actually, is only representing 0.4% of the total forest area. So harvesting is across the country, but it is a very small component. So I hope you understand now how even a volume-based harvesting, annual allowable cut, is calculated. Thank you.